I bought an electric razor Dune Buggy. So when my niece and nephew come to the land out here, they would have something enjoyable to do besides, just wandering through the hills. Well, so I bought one used for $150. It was in good condition, worked fine. I bought it used for $150, brought it out here, and this little grade of land right here, you see, it's not even that steep. That thing struggled to get up just the smallest of inclines. Straight on straightaways, great, no problems whatsoever. It run out there for about 40 minutes on straightaways. But I really want them to be back here to enjoy the nature, and actually, hills are funner, or more fun, I should say. But it just wasn't happening stock. So did a little modifying, and gonna give you the rundown of how everything works. I know this has been done a trillion times over, but still to this day, people are buying the wrong parts and not getting the performance that they want. Well, we got it right the first time. I used a gear ratio speed calculator on I think the site is electricscooterparts.com. I'll leave that link below as well. Yeah, we nailed it first try. I wanted to gain about 5 or 6 miles per hour, but be able to maintain that low end torque. And yeah, let's get to it. Since my speed controller is the easiest to access on this go-kart, we'll start there. And don't worry, I cut the cover to go back on and actually cover most of the wires. But anywho, for demonstration purposes, I unbolted it. But in order to get more RPMs, more torque, power, everything, and I'm not going to go into the whole linear curve of a brush style motor and how it achieves 1,000 watts. I'm not going to bore you with that. You're here to get a blueprint of where to start. You want to stick with the 24 volt motor, but get a 36 volt 1,000 watt speed controller. This is mandatory. I cannot tell you how many posts online I read about people, they'll buy the 500 watt version and then cry that it's, one, running hot as can be, and two, they're just not getting the power that they paid for out of all the upgrades. So do not waste your money. 36 volt 1,000 watt controller is mandatory. So they're either going to come with Chinese writing like this, or depending on the seller, they will label everything for you. But all you really need to worry about is the motor, which is the fat blue and yellow connector, which that's self-explanatory on in US standards. Motor colors, or wire colors I should say, red's positive, black's negative. Well, blue is always positive for international, yellow is always the negative. So you need that. Charging port, self-explanatory. You need that connector. Speed controller. Okay, let's go ahead and integrate this while we're here. The stock speed controller on the Razor, it was very finicky. The kids were going like off, and then on even the little stock wimpy motor, once it hit like the midway point, it would like snap their neck back. So and also they were complaining that when they were going forward, it was hurting their thumb. So I mounted one that was kind of perpendicular, so now they can comfortably grip this, and as it's full throttle, they can just turn the wheel like this, and their thumb sits pretty comfortable right here. And this is a variable speed. You can actually go slow, and then full throttle. I'll show you all that once I get everything back together. But that is self-explanatory as well. So it's going to come with a black wire, so black to black. And this is a 4-pin connector. And this speed controller that I'm going to put in the link description is a 3-wire controller. But all you're going to do is go black to black, red to red. And on the speed controller, the white is the signal for the controller itself. So all you're going to do is put white to green. This red and black connector, you don't even worry about it. So that is how you are going to wire up the speed controller. Alright, so next we have the brake. This is optional as well. Electric motors, once you let off, the torque and everything kind of does a good job of slowing things down, but I went ahead and connected it because the factory Razor has it, so why not? So you'll need to connect that, or you don't have to, but I did. And the last wire you need to worry about, yes, you're gonna have a ton of extra connectors. The last wire you need to worry about is the switch. See this small gauge wire? I didn't want to have anything electrical running through smaller gauges, so I just jumped it. I pinned it, jumped it. And yes, instead of heat shrink, I am using electrical tape, but all connectors have been soldered. I just like electrical tape because it's easy to unpeel and fix soldering joints if I need to. So that's what I decided to go with. Now, I ran my own switch here. I just drilled a hole, ran my own higher gauge switch there, and I got it running off the negative side of the circuit. The stock switch I wanted to keep because I'm running headlights and they are super bright. Matter of fact, I'll show you now. And they're cheap. My kids want, or not my kids, my niece and nephew like to run this at nighttime. So yeah, they're pretty cool. So I use the stock switch for that. Alright, so you definitely want to add your fuse. I ran it off the positive side of the circuit. My switch is on the negative side. It doesn't make a difference though. You can run the fuse straight off the switch if you want, and tuck it into here, and that way it'd be easily accessible. Look, bottom line is this thing's gonna have all kinds of wear and tear. I wanted the fuse. I mean, so wires are gonna get broke eventually, frayed over time. I just wanted the fuse to be easily accessible, so I can literally just pop the cab open, slide a new fuse in, close it, done. So that's why the fuse holder is just kind of hanging out right here. Now the motor. Well, okay, let's backtrack. There's two options when you build one of these things. You can either build it for top end speed, or you can build it for low end torque, hill climbing, etc. I kind of wanted a hybrid. I already know it's going to have a ton of low end torque compared to what it had, but I also wanted to gain 4 to 6 miles per hour on the top end. And since the stock motor gear is not compatible with the stock chain, I decided to upgrade the motor gear to a 14 tooth. And using GPS speedometers on multiple runs, we consistently hit 15 miles per hour with an adult, exactly how we calculated it to be, using the speed calculator on electricscooterparts.com. So yeah, that is pretty much the rundown. It's really not hard at all. I will have the battery circuit drawn up, and yes, I'm literally just going to draw it. I'm not going to be all fancy with it. I'll post a picture of that, and then yeah, the rest is up to you. Alright, if you own one of these, you know how horrible the stock throttle is. I got the rear wheels jacked up on a stock battery just to demonstrate the difference in the throttle. Oops. Let me turn that on. Okay, you know the stock one is either off or on. There's really no in between. So I'm gonna show you the variable throttle first. See, look how you can go really slow. Huge difference. Or you can just slam it right off the bat. This thing is definitely a torque monster. My friend, who is 5'10" and about 135 pounds, yes, he's pretty skinny. But anyways, we wanted an adult to try it first, and yeah, it did 15 miles per hour, downhill, uphill. It's really consistent. Didn't lose speed really at all. It didn't matter what terrain, which my street has a pretty gradual slope there. So on the way back, he also hit 15 miles per hour, which tells me the build is exactly where I wanted it Now my final thoughts on if this whole project was worth it. 1000%. Why? Because I got the go-kart used. Do I recommend going and buying one for $350 and then dumping another $200 into it? No. Because at about $600 you can go get you a 50cc, maybe even a 100cc gas powered kart and have all kinds of fun. But if you want to be different and you can find one of these used for no more than $150, I highly recommend this project, because you get a final project that's, in my opinion, 3 times better than what the factory put out for a retail price. You get way more torque. You get about 6 miles per hour on the top end. And let's face it, 15 miles per hour is still pretty safe for kids. And that Dune Buggy is literally that far off the ground. It's not going to flip. I mean, there's YouTube videos of kids yanking that wheel all the way around, and it just does a little drift. That thing is not going to flip, especially at 15 miles per hour. Like I said, you could eliminate the jack shaft and have a top speed monster go dang near 30 miles per hour. I wouldn't recommend that, because it kind of, I like torque. I like low end torque. So to me, it takes the fun out of it. I like the head jerking action that you get from low end torque. And then it gives the kids a heightened sense that they're really doing something, you know. So yeah, if you can find one of these used, it gets my seal of approval.